Hey guys, so we are going to continue some notes on trig today. So last week we talked about how you find a side using sine, cosine, and tangent. And this week we're actually going to be finding missing angles, okay? So the essential question for this lesson is, how do you find missing angles using trig? And remember, when I say trig, that refers to SOHCAHTOA, sine, cosine, and tangent that we've been talking about for the last week, okay? So for what we are doing today, this is referred to as inverse trig because we are swapping what we're solving for. We're taking the input and making it the output, okay? Or vice versa. Okay, so just a reminder, SOHCAHTOA, sine is what the S stands for. And the ratio that goes with sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. I would encourage you, if you feel like you haven't mastered this yet, to go back and watch the previous video for week 2 and the second video for week 1 that is in the week 1 folder on Schoology, okay? So like I mentioned, this is called inverse trig because instead of solving for the lengths of one of these sides, we are actually solving for theta, which represents the angle, okay? So since that is the case, this equation is going to change a little bit since we're finding the inverse, okay? So we still have our sine, but since we are swapping the input with the output, we are going to put this little -1 symbol to show that we're doing that switch, okay? So that means the ratio will now be on this side of the equation, and what we are getting out of the equation is theta, okay? I know that looks a little funny right now. It'll make more sense in just a second. This, you may also see it written like this. Both of those represent the inverse, okay? All right, same thing with cosine. I'll have the inverse cosine. Now I have my ratio is the input and my output is theta. And likewise, another way to show that it is the inverse is to have the arc in front of the cosine, okay? And then lastly, tangent. We'll have inverse of the opposite over adjacent gives me an angle. This may also be written as arctan opposite over adjacent equals theta, okay? So remember, we are not solving for a length, we are solving for an angle measurement given 2 of the side lengths, okay? All right, so let's jump right in with this first example. Let me zoom out a little bit. Okay, so we are finding the measure of angle C. So let's put our little theta on the C. And it asks us again to round to the nearest tenth, which means 1 decimal place, okay? So you're gonna start the same way you started when we were solving for a side. Label the diagram first with your theta, which we've done, opposite, adjacent, and hypotenuse. Okay, so since this is my reference angle, that's what we're trying to find, my hypotenuse is 10, and then dB, this 4 over here, is going to be opposite since it is across from that angle, okay? We don't know the adjacent side, but we'll still label it, okay? So I know theta is angle C. My opposite side is 4. The hypotenuse is 10. My adjacent side, we don't know, okay? So just like we talked about last week, you want to use what you're given. So since we have the opposite and the hypotenuse links, we are going to choose to use those letters rather than the adjacent side because we don't know the measurement. We could find it with Pythagorean theorem, but that's a little bit more work than we need to do now, okay? So we're not using A. We're using O and H, which is sine. So I'm going to set up my inverse sine equation. Okay, it may be a good idea to go back up where we wrote down these and highlight those. That's what you're going to be setting up when you solve. It's kind of hard to see there. Okay, and then, so we know we're using sine. We're going to plug in what we know from the diagram. So inverse sine, opposite side is 4. The hypotenuse is 10, equals the measure of angle C. Okay, so this is, at this point, you'll have to use your calculator, which if you don't have a graphing calculator at home, that's perfectly fine. Sorry, I'm gonna move the camera here. You can use the Google calculator. Make sure it's again in degree mode. So what you're gonna do this time, instead of just clicking on one of the trig ratios, you're gonna hit inverse, and then you'll see the -1 pop up. Since we're using sine, type in sine. I don't know why they switch and put in arc sine here, but that's correct, okay? Like the notation I mentioned earlier. All right, and then since our ratio was 4/10, we're gonna type in 4 divided by 10, and we get 23.578, okay? So that means the measure of angle C is 23.578 degrees. And since I'm rounding to the nearest tenth, that will be 23.6. The 7 rounds the 5 up. Okay? All right, so again, this is very similar to what we did last time, but we are solving for the angle, but you still are going to start the problem the same way. Label, think about what you're given, and then choose a trig ratio based off the information. Okay? All right, second example. So again, a good thing to do when you're taking notes from a video is to pause, try to do the problem, resume the video, and compare it with your work, okay? All right, so we are finding the measurement of angle R. Opposite is 3, the hypotenuse is 4, and then my adjacent side, we don't know, okay? So I've got theta is angle R. Make this just a little bit. O is 3. The hypotenuse is 4. We do not know the adjacent side, okay? So again, think about what you're given. What ratio uses O and H? And I know that's sine. So I'm going to set up my inverse equation for sine. And then I'm going to plug in what I know from this picture. Okay, so I've got inverse sine of 3 divided by 4 equals the measure of angle R. Okay, all right, so I'm going to go over to my computer. Inverse sine of 3 divided by 4 is 48.59 degrees. Okay, and again, I'm asked to round to the nearest tenth. This 9 is going to round the 5 up to a 6. So I have 48.6 degrees. Okay. All right, so let's look at this last example. Actually, we've got one more after this. All right, so in this example, we are solving for the measurement of angle W, and we are asked to round to the nearest tenth again. So our theta will be here. The hypotenuse is 4.5. And then my opposite side is 3.4. We don't know the adjacent length, okay? So again, label first and then choose your trig ratio that works for this equation next. All right, so I've got H is 4.5, O is 3.4. We do not know the adjacent side, so again, I didn't do this intentionally, it just worked out this way. Again, we're using inverse sine, okay? So inverse sine of 3.4 divided by 4.5 is going to be the measurement of angle W. So I'm going to come over to my calculator. Inverse sine of 3.4 divided by 4.5 equals 49.07 degrees. Okay, that 7 is going to round the 0 up to a 1. So the measure of that angle is 49.1 degrees.